My name is Panagiotis Saliaris, and this is my Lab 4 for the oscillation of a spring mass system. Introduction. In this lab we are examining the motion of a spring mass system where the mass swings in an arc while oscillating on the spring. Using the data gathered from Tracker in a CSV file, we are then going to use a model to chart the different energies involved in our system. These energies include the kinetic and potential energies involved in our system from both the spring and gravitation, all changing due to energy principle. The time interval that this occurred over was 9.33 seconds. Here I have provided the equations used in my GlowScript code while solving this lab. Here's my tracker video. I used the tracker video in option 1 to extract the position data of the mass in this video located in the course document files. I will now play my video. As you can see, the spring moves in a pattern direction, almost like a circle here. You can see, from the graph here, you can see it goes up and down the same way. Tracker. After having set up the coordinate axis and used our known distance of 0.7 meters, I charted the path of the weight on the string providing this data. With this, I was able to along our initial information with the mass equal to 0.402 kilograms to calculate our K using the equation K is equal to 4 pi squared times mass over r squared, where T represents the interval between our oscillation, giving spring constant of 6.836. And this is the equation used to solve for mass times gravity. And we have the L here to be at 0.124 meters. Here you can see these two positions are locations of interest where the spring has reached this location. And so here's my GlowScript code that I used. And starting, I initialized the values that were provided and calculated based on the data from Tracker, setting the values like K_S to the spring constant found using the oscillations as well as the initial energies using the previous formulas. After this, in the loop, I coded the forces involved using the fundamental principles we've previously learned and then updated our ball's velocity and position. Following this, I updated the separate energies and found their change over the previous time interval to then be graphed. And here is where it's all shown. And so here's my GlowScript model running. As you can see, like in the Tracker video, it moves in that same circular, almost oval shape, and it continues to do that. You can see it goes on and on until it forms this pattern here. And see, here are my GlowScript graphs for the position versus time and the change in energy versus time. And so what does it mean? For the used oscillations for the lab Y, the oscillation times resulted in the spring constant of K equal to 6.836, while the oscillations for the position in the X direction resulted similarly with a spring constant of K equal to 6.792. This clearly shows that the oscillations in both the X and Y directions followed the same timings as the mass oscillations if this were to occur.